Thank you for joining our webinar today, Artificial Intelligence in Animal Health and Nutrition with Eurofins Testing Solutions. Today's webinar will be hosted by Leo Schilling, our Senior Scientific Services Manager at Eurofins SF Analytical Laboratories. My name is Drew Wellnitz, and I'll be the moderator for today's webinar. All right, that concludes my brief introduction. I will now pass it on over to you, Leo.
Thank you, Drew. And thank you everyone for joining this morning. For everyone who's at least in North America, and for everyone else, good day to you. I'm gonna turn off my camera a little bit just to save a little bit of bandwidth for you folks who have a little bit of struggle with your internet connections. But I'm excited to talk to you today about the artificial intelligence that is being used in agriculture and animal protein production industries. Today's presentation is going to focus on highlights on AI and machine learning and how it's transforming the commercial agriculture sector. Also how AI predictive analytics enhance crop predictions and weather forecasting, robotics in livestock and waste management, and we'll wrap up with a couple of examples on how AI is enhancing precision agriculture and drone technology. In the last presentation, so this is part 2 of this series, and you know, I wanted to go over the historical milestones with you in AI, you know, before we start talking about the agriculture piece, because a lot of people feel like artificial intelligence is something new, but you know, it's been around for quite some time. Before we begin looking at the topic, you know, highlighted in today's presentation, you know, there are these historical milestones, you know, just to review. So the foundations of electronic neural networks were actually first established by Warren McCulloch and Walter Pitts in the 1940s, drawing parallels between the brain and computing machines. In the 1950s, mathematician and computer pioneer Alan Turing proposed the Turing test. Alan Turing published Computing Machinery and Intelligence, which proposed a test of machine intelligence called the imitation game. The first chatbot, Eliza, was invented in 1966 at MIT. It was an early test of a machine's ability to produce intelligent behavior that was equivalent to a human's. The 1990s did see a resurgence in AI with groundbreaking achievements. In 1997, IBM's Deep Blue defeated chess champion Garry Kasparov, showcasing the analytical and strategic capabilities of AI. And the Loom project in 1996 laid the foundation for generative AI's rapid development. AI also made significant advancements in the 2010s. In 2012, a neural network set records in image recognition. In 2014, generative adversarial networks, or GANs, revolutionized AI creativity. And that's really kind of the spark, you know, that really got AI in the forefront in terms of ChatGPT and really the presence that it has today. OpenAI was founded in 2015 to advance AI for humanity. In the late 2010s, we began approaching the ability to replicate human speech with artificial intelligence. And next, you know, we did go through a few, you know, background items in the last presentation. So here in this first part, just kind of review some of that with you. So first, just kind of focusing on some key applications of AI in animal health and nutrition. There is automation. So automation of feed formulation for optimal nutrition and monitoring of animal health through predictive analysis are key components of AI in agriculture and the animal health and nutrition industries. By leveraging AI technologies, producers can precisely tailor feed composition for different livestock, ensuring optimal growth and health outcomes. Additionally, predictive analytics enable early detection of potential health issues in animals, allowing for proactive interventions to maintain their well-being. These applications demonstrate how AI plays a vital role in enhancing the efficiency and effectiveness of farming practices. So first, just kind of want to go over what is Agriculture 5.0 as a concept. So just kind of talking about some predictions and trends in AI farming. The future of agriculture of AI holds immense potential for growth and development. And just these are some key predictions here and trends for AI in farming. So there should be some increased adoption of precision agriculture techniques powered by AI, which is going to lead to sustainable production practices. Integration of AI technologies with UAV sensing, IoT, which is Internet of Things, and cloud platforms for real-time decision-making. Augmentation of precision farming practices with smart sensors, automation, and agronomic activities. and predictive analytics. Continued development of AI-driven tools for crop monitoring, disease detection, and resource optimization, and emphasis on interdisciplinary research and collaborations with policy support to drive the growth of intelligent digital farming. And these predictions and trends highlight the immense opportunities AI offers in transforming agriculture, making it more sustainable, efficient, and technology-driven. This is just, I think, a really cool diagram. It's pretty old, actually, but this is, just kind of exemplifies some of the real-world applications of AI in farming. I mentioned earlier the Internet of Things, IoT. It's essentially a network of devices that can be connected and exchange data with other devices and systems over the Internet. So IoT devices can include mechanical and digital machines and consumer objects. They're often found embedded with sensors, software, and other technologies. AI technologies have found numerous real-world applications in the farming industry, revolutionizing the way that agricultural practices are carried out. And these are just some common examples of how AI is being applied in farming. So in this example, there can be crop monitoring and disease detection using machine learning algorithms, automated irrigation systems based on predictive weather models, drone technology for crop monitoring analysis, smart pest control systems and weed control systems powered by AI-driven sensors, automated harvesting equipment powered by machine learning algorithms. And we'll also go through some case studies too, just to go through some specific examples a little later in the presentation. Sensors are being used to inform automation supporting herd health maintenance and feed formulation for optimal nutrition. So this is a diagram of what can be considered a connected cow. Connected cow technology, there are various products actually currently on the market that have the ability to do these things. They're essentially wearable sensors. Some of these are designed actually to be swallowed as a bolus, and we'll just stay inside of the cow to monitor critical parameters like milk production. So tracking a cow's body temperature, pulse, and daily movements can help producers manage milk production. Monitoring a cow's heat cycle can help smooth the calving process. Early diagnosis of illness can reduce the risk of mortality and the number of times a sick animal needs to be treated. Tracking a cow's rumination activity can indicate whether it's eating and digesting properly. And using narrowband IoT technology, a tracker can provide a cow's real-time geoposition, making it easier for producers to locate their cattle. Monitoring animal health through machine vision and predictive analytics is also kind of a hot topic. By utilizing predictive analytics, producers can monitor the health of their animals proactively. This involves analyzing vast amounts of data to forecast potential health issues before they become critical. Using machine learning algorithms, patterns, and trends in animal behavior, it can be identified, enabling interventions to be implemented early. Predictive analytics can improve animal health care by providing real-time insights and alerts to producers, allowing for timely actions to maintain the well-being of livestock. And this proactive approach enhances the overall animal health and welfare. So Eurofins does offer some AI-powered analytical support. So by utilizing these AI algorithms and analyzing big data is going to allow improvements in safety and quality for animal feed and livestock production. But you'll need to sync that with a third-party testing provider to get you some more of the answers that's going to complete your data package. Data acquisition and monitoring can be used to detect contaminants to ensure compliance with regulations, which supports increases in efficiency and accuracy in techniques that are used to select samples for testing processes through automation. These processes can also be used to monitor and track feed composition and optimize nutrition for livestock and allow producers to stay ahead of emerging risks and trends in the industry with data-driven insights from AI analysis. The next section here is just talking about some AI-driven predictive analytics in agriculture. AI-driven predictive analytics will revolutionize the industry by optimizing crop management through data-driven insights. These leveraging machine learning algorithms will allow us to develop sophisticated algorithms, which can lead to producers receiving a forecast for crop yields with precision. Integrating AI into weather forecasting empowers producers to make proactive decisions based on real-time weather data, enhancing operational efficiency. And this innovative approach not only predicts yield, but will also help in mitigating risks associated with adverse weather conditions. For example, enhancing the yield in crops. So incorporating AI with agriculture improves crop yield predictions through analyzing huge amounts of data, as I previously mentioned. By employing machine algorithms and machine learning methods, this process can analyze unstructured text from sources like weather reports and historical farming data. And this will enable predictive models to forecast optimal planting times, irrigation schedules, and pest control measures. Through semantic analysis and statistical methods, AI enhances decision-making by providing actionable insights based on complex data sets. And implementing data-driven predictive analytics not only boosts productivity, but also maximizes resource efficiency, ultimately contributing to sustainable agriculture practices. AI's role in enhancing crop yield predictions showcases its transformative potential in modern farming practices. Weather forecasting in agriculture is vital for optimal crop management. AI applications enhance accuracy by analyzing large data sets for predictive modeling. It enables real-time weather updates, aiding producers in making informed decisions. And by utilizing machine learning algorithms, AI predicts weather patterns with precision, optimizing planting and harvesting schedules. Implementing improved forecasts mitigate the risks of crop damage due to adverse weather conditions, resulting in better productivity. And harnessing AI and weather forecasting also empowers producers to mitigate climate change related challenges effectively. And here we have just a kind of a really interesting case study. One compelling case involves a large-scale farm that utilized AI-powered predictive analytics to optimize irrigation scheduling. By analyzing vast amounts of data, the system accurately predicted soil moisture levels, enabling precise irrigation, ultimately leading to a significant increase in crop yields. Now we have a kind of an interactive poll for you today. So we have two questions just to keep your interest going, and I am interested to see what kind of comments you have. So question one is, what are some of the key AI technologies that are being used today in commercial agriculture practices? I'll give you just a moment to consider that. Drew, can you confirm that the poll is open?
Yep, it is open.
Perfect, thank you. Give everyone just a moment to respond there. What's the consensus looking like, Drew?
There are the results.
Very good. All right, so AI technologies like machine learning, computer vision, and predictive analytics are revolutionizing commercial agriculture, as I previously mentioned. These innovations enable precision farming, smart monitoring systems, and data-driven decision-making for increased productivity and sustainability. All right, folks, next section, we're going to be talking about robotics and automation in agriculture. So the integration of robotics and automation in agriculture represents a significant advancement in modern farming practices. Automated feeding systems have revolutionized the way that livestock is managed, leading to improved efficiency and productivity on farms. Additionally, waste management solutions powered by AI technology have enabled farmers to reduce environmental impact while optimizing resource utilization. Robotics play a key role in streamlining repetitive tasks, allowing farmers to focus on more strategic aspects of their operations. And by leveraging these innovative technologies, the agriculture sector is poised to achieve higher levels of sustainability and profitability. Automated feeding systems represent a significant improvement in agriculture practices, leveraging AI and robotics to optimize livestock nutrition. By incorporating natural language understanding and advanced algorithms, these systems can interpret complex data to dispense customized feed modifications efficiently. This technology not only streamlines feeding processes, but they also enhance animal health and productivity. These innovations go beyond traditional methods, incorporating sentient analysis and speech recognition to a precise feed distribution. The real-time monitoring capabilities of automated feeding systems revolutionize farm management by providing farmers with immediate insights into their livestock's dietary needs. And this integration of technology marks significant advancement in modern agriculture. We also have waste management to consider. So, it can be improved by AI-driven solutions. From reducing food waste, optimizing resource utilization, AI solutions can be applied for the overall goal of reducing waste. By leveraging machine learning methods and natural language understanding, AI systems can efficiently process large volumes of data to streamline waste management process, identify patterns, and also suggest improvements. Waste management powered by AI not only enhances operational efficiency, but it also contributes to the sustainable practices in agriculture. And these innovative solutions highlight the potential of AI in transforming traditional farming methods towards a more sustainable future. Next, we're just going to be talking a little bit about computer vision, and how that can improve farming practices. So utilizing computer vision in agriculture enables enhanced crop and animal health and behavior monitoring. By analyzing visual data, producers can identify anomalies and track patterns in weather and livestock activities. This technology is useful for monitoring animal well-being, detecting signs of distress, and also ensuring that optimal living conditions are met. From identifying individual elements and animals to tracking herd behavior, computer vision offers real-time insights for proactive decision-making. Additionally, it aids in behavioral analysis, ensuring that there's early intervention in cases of irregularities. Implementing computer vision in agriculture not only enhances productivity, but it also promotes the ethical farming practices by prioritizing the welfare of the workers and the animals. Question 2, we got another real-time poll question. So what is an example of an AI application used in commercial agriculture? And we've got some options for you to choose from.
All right, poll number 2 is live.
Thank you, sir. Give everyone just a moment to respond to that. All right, thank you, Drew. So AI applications in commercial agriculture include precision farming for optimized resource use, drone technology for crop monitoring, and predictive analytics for pest control. Robotics aid in harvesting, while computer vision ensures livestock health. And these innovations revolutionize modern farming practices and are just a few examples. Let's move on to the next part of the presentation. So there are some good innovations in livestock management by utilizing AI. So livestock management has been transformed and streamlined through AI integration. The advent of AI has improved monitoring and care practices, enhancing animal welfare and productivity. By leveraging sentiment analysis and real-time data processing, farmers can now detect anomalies in animal behavior very promptly. Additionally, AI-driven systems enable predictive analytics for early disease detection, ensuring that there's proactive health measures for livestock. These advancements in livestock management exemplify the synergy between technology and agriculture, optimizing operations and promoting sustainable practices. With AI's ability to progress and process large volumes of unstructured data, the future of livestock farming will be improved efficiently and will see improvements in animal well-being. AI technologies have also improved real-time monitoring and disease prevention in agriculture. By implementing sensors and AI algorithms, producers can continuously monitor herd and crop health and detect early signs of disease promptly. This proactive approach enables timely interventions, reducing the risk for crop loss and ensuring higher yields. Furthermore, AI aids in predicting disease outbreaks by analyzing vast amounts of data, including environmental factors and historical patterns. Such predictive analytics empower farmers to take preventative measures in advance, safeguarding their crops against potential diseases. And overall, the real-time monitoring is rapidly enhancing the health and resilience of agriculture systems. Another case study here. So there's a noteworthy example here that's is the application of computer vision for weed detection on a vineyard. By leveraging machine learning methods, the system identified and eliminated weeds effectively, reducing manual labor costs and enhancing overall farm productivity. And these successful implementations highlight the transformative potential for AI in revolutionizing modern agricultural practices. The final section that we're going to be talking about here today is focusing on AI applications and data auditing for farm management. So AI applications and data auditing for farm management play a pivotal role in optimizing operations. And by utilizing natural language processing techniques like sentiment analysis and entity recognition, farms can streamline compliance processes. These applications aid in extracting key insights from unstructured data, enhancing decision-making for producers, leveraging machine learning methods, which allows for accurate text classification in auditing and farming records efficiently. Implementing AI in agriculture production systems streamlines data management, allowing for improvements in compliance and reporting processes by automating data collection, analysis, and regulatory requirements. This technology enhances efficiency by interpreting complex regulations through natural language understanding and semantic analysis and entity recognition. By utilizing machine learning methods, AI systems can ensure accurate and timely reporting of regulatory data, reducing human error and manual effort. Additionally, AI applications in compliance management provide real-time insights into regulatory changes, enabling proactive adjustments. And overall, AI facilitates seamless compliance and reporting in agriculture, mitigating operational risks and optimizing decision-making processes. And the integration of machine learning methods and sentiment analysis also allows for the extraction of valuable information from unstructured data. These insights they're very useful in determining optimal planting times and resource allocation and pest management strategies. Advanced text analytics and natural language understanding empower producers to interpret vast amounts of data efficiently and enhancing their decision-making capabilities. With AI-driven tools such as language models and statistical methods, farmers can leverage real-time information for precise and strategic actions in crop management, ultimately leading to an improved agricultural productivity and sustainability. So harnessing these data insights revolutionizes the data decision-making process in commercial agriculture. There are going to be some challenges, and principally, those hurdles in AI solutions in agriculture are really focused on addressing data privacy and security concerns. The sensitive nature of agriculture data, including crop information to financial records, necessitates robust measures to safeguard against unauthorized access or data breaches. Furthermore, tackling the technical skills gap in rural areas also poses a challenge. So both of these issues can be addressed by providing adequate training and support to operations managers and agricultural workers to leverage AI technologies effectively, which is necessary for successful implementation. So overcoming these obstacles requires a multifaceted approach that combines education, awareness, and technical support to ensure that there's a seamless integration of AI in the agriculture sector. And finally, we don't, Eurofins doesn't develop AI solutions ourselves, but we do have a way of integrating with your networks. So if you have interest in updating to this type of technology, by all means, please do connect with us. You can always send us a message at info@eurofins.com. If it is a feed or food or animal health related topic, I also encourage you to use the email address here listed on kind of the middle bottom part of this slide, which is eurofinsanimalhealth@ ft.eurofinsus.com. And you can also scan that QR code that would take you to our animal health website to read more information about these topics and also about the services that we offer. And with that, thank you for joining today. And I encourage all of you to continue your learning about this powerful new technology and what it can do to improve modern farming practices. With advancements in predictive analytics and robotics and computer vision, and agriculture producers can optimize their operations like never before. But do stay aware of the challenges like data privacy and skill gaps that will need to be addressed for effective implementation in your facilities. So thank you very much. And with that, I will be happy to take some questions if we have any.
Right. Thank you, Leo, for your presentation. We'll now move into the short Q&A portion. Feel free to continue to submit questions throughout this session, and if we do not get to your question live, we will follow up with you after today's session. All right, so it looks like our first question will be, how can small-scale farmers benefit from AI?
By utilizing AI, small-scale farmers can enhance crop monitoring, optimize resource usage, and receive real-time insights, for better decision-making, kind of the same as the large producers. This technology aids in increasing productivity and efficiency, so even small farms, can get benefits, which would lead to, improved yields and more sustainable farming practices.
Thank you. All right, our next question is, are there any challenges or limitations to using AI in commercial agriculture?
Definitely, yes. The data privacy issues, as I previously mentioned, and the technical skill gap, particularly in more rural areas, I think are going to be the most challenging on the front end. And of course, there is the initial setup cost. So that can be prohibitive, for a lot of companies. Limitations may also arise from the need for reliable internet connectivity. So there are a lot of rural areas that suffer from reliable data coverage from an internet connection, and that there can also be potential resistance to adopting new technologies. So those are just a few examples, but certainly things that can be overcome.
All right, thank you. The next question is, are there any examples of successful implementations of AI in commercial agriculture?
Yeah, definitely. It's new, but as I mentioned here, I think once or twice here in the presentation, precision farming techniques are not very new. I mean, that's been really developing for about the last 10 years. So precision farming techniques for crop management and drone technology for aerial imaging. And these advancements have really led to increased efficiency and higher yields in modern farming practices already.
All right, it looks like we have a couple more here. The next question is, how can farmers integrate AI innovations into their existing agricultural practices for maximum benefit?
Depends on the industry. It did kind of take a broad cross section here. I think we have a pretty wide variety in folks listening today. Whether they're producing crops or animal protein production, but regardless, there can be increases in optimizing yields, monitoring livestock or crop health. And then making data-driven decisions by incorporating just large data sets that previously wouldn't have been able to be analyzed by humans. And predictive analytics, robotics, and computer vision, all of those things are really going to be important for improvements in efficiency and sustainability.
All right, looks like we have one more question here that reads, do you have any recommendations for further references on this topic?
That's a great question, and it really depends on your region. It's a new area, and so there are a lot of trade publications. But my personal preference is really going to the regulatory sites. So if there are regulatory bodies out there, depending on your region, I would take a look at what information is available for us in the U.S. I'd look at the USDA and FDA, and find out if there's any current positions or statements on this technology. And beyond that, of course, there's just really an explosion right now of articles on these topics, you know, in trade publications. So I definitely encourage you to look at those. But you know, a lot of that can be skewed as you know, it can be you know, part of marketing targets. So it's important to, you know, use your best judgment and your background understanding of this science, you know, before making a decision to you know, purchase a system or invest in a system.
All right, thank you. So that will wrap up our Q&A session. Thank you, Leo, so much for your expertise and your presentation, and thank you everyone for attending.
My pleasure, Drew. Thanks everyone. Have a good afternoon.